Hello, my name is Vishal. I have Brian and Matthew here as well. We are Team Smart. We are presenting you our project called Smart Garbage Bin. So let us begin. First of all, we all want less of this and more of this, correct? We need to understand the cause behind it. Why is this happening? According to the US Environmental Protection Agency's website, in the following graph, you can see the trend of plastic waste management over the course of 57 years. I would like to draw your attention to year 2070 especially. Only around 2.3 million tons of plastic is recycled out of total of 35 million tons, where the vast majority of 27 million tons is landfilled, only in 2070 alone. If landfill trend continues, it is expected by 2050 there will be 12 billion metric tons of plastic in total landfills. That amount is 35,000 times as heavy as Empire State Building. It's a lot. A lot of times sorting garbage is an issue, which causes recycled item to go into the landfill category. We also found out the waste sorting facilities often can't retrieve some of the mixture of plastic from landfill waste. So in order to address this issue and reduce the landfill and help maximizing recycling of plastic, our team has came up with the solution using today's machine learning and computer vision technology. We have designed a smart device that can be implemented on any existing garbage bin. As shown in CAD design, there is main module consists of Raspberry Pi cam, and there are three categories of garbage bin with each with its own LED. So the idea is to help user with garbage throwing practices. For example, I'm unaware of recycling things and I want to throw plastic bottle. I'm not sure which category I should go with. Our module will detect the bottle and turn on the recycling bin's LED will let the user know that it belongs to the recycle. It performs object recognition using Pi and Pi camera. So the motivation behind this project is by taking help the computer vision, we want to improve upon recycling and help reduce the unintended landfills. So I'm going to give an overview of circuit design. We used the Raspberry Pi Model 4B along with the high resolution Pi cam and some LEDs. Due to coronavirus crisis, we were not able to implement the features like motion detect using motion sensor and full bin detection using the ultrasonic ranger. We wanted to make sure that we help user in the right way. Our prediction should be the correct. We don't want to guide them or false claim that they should be in this bin instead of this bin, And then again, we wanted to make sure that it is a low cost solution. Also at the same time, it is a low power. If you can see, we have it here. And then if we go to the next slide, mentioned that our power consumption should be less than 1 watt per day according to that IEEE standard, and then bin should be able to communicate with the maintenance. We are not able to implement that part, but we were trying to create a way that once the bins are full, we can let the maintenance know that this is the time for change the bags or something. Alright, so thank you for listening to me. I'm gonna hand over to Matthew now.
Our main objective was to design a device that scans garbage presented by the user and then tells the user the correct bin to put it in. When we were coming up with a preliminary design for our device, we had a variety of factors we had to consider. The first of which was whether our device was going to be indoors or outdoors. We decided our device was going to be an indoor device. Next, we had to decide what source of power we were going to use, a battery or an outlet. For our device, we chose to use an outlet for a more stable power source. Next, we had to consider what was going to be the brains of our machine, the microprocessor. We had narrowed it down between an Arduino or a Raspberry Pi because they're both easy to work with. We decided on using the Raspberry Pi because of how well supported it is by the community and how powerful the device is. These three design specifications remained the same for all of our design alternatives. Our first design was our premium design. Our premium design was a 2-camera system with live-time scanning and infrared sensors to determine when a user was near. It also had trash compacting and used ultrasonic sensors to determine when a trash can was full. When this occurred, it would call for maintenance via email. Our final design was a one-camera system with place and scan instead of live-time scanning. Live-time scanning was faster, but it was too inaccurate. Our final design, we also had to do away with trash compacting, ultrasonic sensing, and calling for maintenance due to budget and time constraints. Our final design is our simplest design that accomplishes the core objective of our project. It scans the image of the user's garbage into the system and outputs the correct bin to the user by simply lighting an LED.
There were several ways that we thought about solving this problem. The way that we decided to go with in the end was training a convolutional neural network through TensorFlow. So the model consists mostly of 3 convolutional layers, 2 fully connected layers, then 1 final softmax layer. For the classification, we had 6 subjects. We had glass, paper, metal, plastic, cardboard, and landfill. We decided to break up the classification into more specific categories like that instead of just doing the 3 bins that we're going to have, the paper, recycling, and landfill, just so that the model could hone in on specific characteristics that all these materials have instead of just trying to convince the network that glass, metal, and plastic are all the same thing, in the recyclable category, even though they all have their own unique traits. And that's definitely something we would want to do in the future, is make a lot more categories and get a lot more specific so that we can let the network specialize even further, and then we'll lump them into the respective bins afterwards, which is what we're doing now to a certain extent with the glass, metal, and plastic. We throw that all in the recycling. Cardboard, paper, we throw that in the paper bin, and then landfill, and anything that we can't classify, we just tell it to go to the trash. And probably the biggest thing restricting us from doing even more categories than we are now is just getting the training data for that. Like as of right now, we actually used some open source data that we found, and then to make the training set even more interesting, we used defined matrix transformations. We rotated the image about 10 degrees and took the picture there, so we got about 36 extra images per 1 data point. We also added Gaussian noise to these images to multiply our data set even further. So in the end, after a lot of training, we were able to get, as you can see here in this image, about a 92% accuracy on validation data. And we ensured that this validation data was completely new to our model by separating the parent images before we rotated them and added noise to them. So the validation data was completely unseen by our model. We're going to be classifying garbage into landfill, recycling, and paper, corresponding to these 3 LEDs: landfill, recycling, paper, cardboard. We'll start with a plastic milk cap. It's recognizing that as recycling. Now we'll do a glass bottle. It's recognizing that also as recycling. Now we'll move to kind of a wad of trash. It's seeing that as garbage. Next, let's try the metal can. It's seeing that as recycling. Now let's try a big piece of cardboard. Seeing that fall over as well. Stop sliding over. All right, it's cardboard. Now, just a nice sheet of paper. See what it thinks that is. It's recognizing it as paper. Oh. And my note sheet. Paper. In the end, we were all pretty happy with what we were able to achieve. The classification worked pretty well. That was the first part of our design, being able to go up there and place a object to get classified in the proper bin. I think we were all a little bummed that we weren't able to get the full live time scanning going completely that we wanted to, where you could just walk up to the can and it would already know where to put your garbage. Our live time part of our model was just a bit too finicky to give us reliable boxes to then put our classifying program inside of those boxes, so we had to leave that out. But I think if we were able to work at this for maybe another month or two, we probably could get to the dream of having the live time scanning, where we would just be able to walk up to this thing and it would give us a good idea of where we should place our trash. And in the end, I think we're all pretty happy with that outcome. And I'd like to thank you for sticking around and listening to our whole presentation.